people have always been playing around with numbers, and as they play around with them, they have to create more interesting numbers so that the equation makes sense. So, for example, it used to be that there was just whole numbers. Whole numbers are 1, 2, 3, and so on. Now, people had the idea then, if using subtraction, of subtracting something by itself. Now, for a while, there was no answer to this. It just didn't make any sense. You would say nothing. But there was a time when 0 had to come in to our world. And so we take it for granted that 0 had to be invented at some point. And likewise, people started to do something like subtract larger numbers from smaller numbers. And for a long time again, this was considered just nonsense because you can't take away more than what you have. But eventually, we had to get into accounting where people had debts, and this actually did make sense, so we invented the negative numbers. Now, the same thing can happen with division. So people had no problem with 4 divided by 2. But then what about 2 divided by 4? Well, 2 divided by 4 is not a whole number, and they eventually started working out fractions. So people started to expand the types of numbers that they used. They started with whole numbers, but then they had 0, they had negative numbers, they started to include rational numbers, or fractions. And then finally, when square root came around, the square root of 9 made sense because they asked themselves what could times itself would equal 9. Well, as we've been doing, we write it 3 times 3. But if you were to do something like negative 9, when you factor this out, it's negative 1 times 3 times 3. The 3 can escape, but they just kept having issues with this negative 1. So around the 1600s, people started to see this come up in their mathematics, and it was really useful, but they couldn't make sense of it. So a lot of people called this absurd. They called it just imaginary numbers that we use to find an answer, like a stepping stone. And we know now that we just call this I. So, remember this. I squared will give you negative 1, and I is the square root of negative 1. And it's really useful when we do things like get a square root of negative 36. You think of it like negative 1 times 6 times 6. The 6's will escape. The negative 1 is still trapped, and so we just write it 6i. Yes, it's called imaginary, but they're actually incredibly useful. So let's do another one of these. What if we did the square root of negative 24? We simplify like we always do. We factor 24, we get negative 1. We get 3 and 8, which would be 3 and 2 and 2 and 2. So I'll write that here. And then if I circle pairs, we still have, even though the 2 moves outside, a negative 1 and a 6. Okay. The square root of 6 stays there. And then whenever we see square root of negative 1, we just include an I. So another way to say it is that if you have a negative 1 in a radical, you can have it escape as long as it's I outside. So this would be the simplified form. Okay, so there's something called standard form with complex numbers. The standard form is a plus bi. Okay, so let's just look at a few numbers here that are all complex numbers, and you could rewrite it in standard form, like negative 6. You might think there's no imaginary part, but actually, you could rewrite this as negative 6 plus 0i. If you don't have a complex part, the complex part is just 0. Similarly, with 5i, you could rewrite this as 0 plus 5i. And so you have this real part, and then you have this imaginary part. Also, these things can be fractions and so on, so if you see something like 5 halves plus 3i, still, you have the real part, and then you have the complex part, or the imaginary part. whoops, meant to do that as the same color. So what happens is sometimes you'll have something like 2 plus 3i all divided by 5. That's not in standard form. You just have to break it apart using the butterfly. So you'd write that as 2/5 plus 3/5 I, so that you can identify the different parts, the real and complex. Okay, so you're going to start taking these numbers like 5 plus 2i. You're going to do things like subtract them, which is not that complicated. You just do like terms. And just be careful when you do this, because you have to make sure that you're subtracting both of these. So 5 minus 7 is negative 2. 2i minus 3i is minus 1i. And there you have it. That's not that hard, but when you start to multiply and divide, there's more work that you have to do. So for example, if you have 2 plus 3i times 5 minus 7i, you can't just multiply the reals and the non-reals. What you have to do is expand it. So 2 times 5 is 10. 2 times negative 7 is negative 14i. 3 times 5i is 15i. And then here's the interesting part. That's going to be negative 21, and I times I is I squared. So write it out. Don't be a hero here. Now every time you see an I squared, you know, based on what we wrote before, that's like saying the square root of negative 1 squared, which would be negative 1. And so basically, that's just going to turn this negative 21 into positive, because you'd be multiplying by negative 1. So if we turn that to be positive, that would be 10 plus 21, which is 31, minus I. So our answer there is 31 minus I. Alright, so you should pause this video and you should give it a try. What if I gave you something like 4 minus 2i and squared it? Try expanding that. Okay, so we write it twice. In our mind, we're thinking, all right, there are 4 minus 2i's. So foiling this out, expanding, we get 16. We get negative 8i. We get negative 8i again. And then we have plus 2i squared. So 16 minus 16i plus 2i squared. And again, this I will basically make this positive 2 negative 2, and that will combine with 16. So I get 14 minus 16i. Okay, so that was multiplication. What if we had to do division? All right, here we are. There is a division problem, and basically you're not going to divide the way you normally divide other things. You're going to be doing the conjugate. Just like when you had to rationalize, what you're going to do is actually multiply by the conjugate on top and on bottom. So we're multiplying by a fancy 1. Now just to be clear here, conjugate means that you take only the complex, the imaginary part, and make it negative, or the opposite. So if I have negative 1 plus 3i, the conjugate would be negative 1 minus 3i. If I have something like just 2i, the conjugate is negative 2i. Now if I have a number that is like 6 plus 0i, so I would just write 6, the conjugate is still itself, because if you make 0 negative, it's the same as itself. And just be careful. If you have something like negative 2 minus I, the conjugate is going to be negative 2 plus I. You don't touch the non-imaginary numbers. Alright, so here's what we have to do. We have to FOIL the top and the bottom. So I'm going to try to write this out really clearly. 26 times 2, 26 times negative 8, that comes out to be negative 208i. This will be 4i down here, and this will be negative 16i squared. So when I work this out, 52 minus 204i minus, and if you're getting used to this I squared, you could just write this as plus 16. So when I write out the top here, I'm thinking 52 plus 16 is 68 minus 204i. That's just the top. Now for the bottom. Alright, the nice thing about the conjugate and why this works is that this is the difference of squares. A plus b, a minus b. And so remember, whenever you have a plus b, a minus b, and you FOIL it out, you're going to have the middle terms cancel. So this is going to turn out to be a squared minus b squared. In this case, since a is 2, you'd have 2 squared minus, and b is 8i squared. So this would be 4 minus 64i squared. And remember that I squared makes it a plus, so it's going to be 4 plus 64. Final answer is going to be 68. Now, if you don't like using this trick here, then just expand it like normal and you'll get 68 still. So if we put 68 below here, we have our answer, but it's not in standard form yet. We always want to butterfly, and so my final answer is going to be 1 minus, and when you divide that out, that's actually 3i exactly. Alright, if you want to give this a try, here is a try problem that you can do. 8 minus I all over 2 plus I. You can pause the video and give it a shot. Okay, so if you work things out, I'm not going to show all the work here. You're going to get 3 minus 2i as your final answer. So just make sure you're doing this. You're multiplying this by 2 minus I, and the top by 2 minus I, and FOILing each out and doing the butterfly.